Okay, so far this year we've been dealing with graphs, and all the graphs that we've been looking at have been straight lines. And just hopefully as a little bit of a reminder, all your straight line graphs have been in the form of y equals mx plus b. And in actual fact, I'm going to change it to mx plus c because in senior school next year, it's just changed to mx plus c recently. They've gotten rid of the b and changed it to c. Does it make any difference? No. Now, though, in this particular video, we're going to be dealing with the parabola. Now, hopefully, you might remember that the parabola is a shape and it is a curved shape. And of course, it can be curved up or curved down. And it's funny, we often refer to these as concave up or concave down. Okay, and the concave up one has what's referred to as a minimum point. In other words, it has its lowest location or lowest point before it starts moving up again, whereas a concave down parabola has a maximum point, or we often refer to as a turning point. But the thing to know about parabolas is they deal with everything in their equations has this square in it. So whenever you see an equation, for example, that looks like y equals x squared, or you might have y equals x squared plus 1, or you might have minus x squared minus 1, for example, because they have that square in it, straight away you know that you are dealing with a shape that is parabola shape. Now, it, for example, could be anywhere. It could be over there on the graph. It could be, over there on the graph. It could be going down on the y-axis. The location of the parabola can be all over the place. It actually depends upon the equation given to you. However, the fact that it is a parabola is because of this square. And we will do other ones later with the cube and with fractions in them and show you what those type of graphs look like. So let's look at the example that we have here. It says copy and complete this table of values. Y equals x squared, where the values x are taken from -4 to 4. First of all, you might notice that they're actually dealing with a larger amount of x values. If you remember back in year 8, when we were graphing straight lines, we often only had to use a few values, and you might use 0, 1, 2, 3 to work out the y's, because if you think back to it, what do you really need from a straight line? You actually only need 2 points to draw a straight line. The only reason we have the extra points there is to make sure that we haven't made an error, that one of the points was wrong. However, with a parabola being a curve, it needs more points because, for example, if I just use one of these over here, you need to show where the different points are, and you need to show where the lowest point is, for example, and then where the points start to come up again on the right. So hence we have to use a lot more points, and they also encourage you to do 0.5s as you get closer to the 0. And in some cases, I would actually even encourage you to do 0.25 or a quarter. The reason is it gives you, as you get closer with the parabola, it gives you a nicer smooth curve down this bottom. If you don't have that 0.5 in, it just looks like sometimes like a flat bottom, and you don't really get an idea of what the curve looks like. Okay, so I'm just going to rub those out just so that we don't have all that excess there that's not needed. So these extra points here, the 0.5, the 0.25, are to make the curve, the turning point, smoother and nicer. Okay, so let's start looking at how to solve this. We've got to put in y equals x squared. So here's my formula. So I have my formula, y equals x squared. The first value I'm putting in is -4. Now notice the x is -4, so it is -4 squared. Okay, I'm actually squaring the negative and the 4, and when you square both the negative and the 4, you get positive 16. Okay, and then the next one is y equals negative 3 squared, which is going to be 9, negative 2 squared, which is 4, negative 1 squared, which is 1, negative 0.5 squared is going to be a quarter. Now, in case you've forgotten that, or how that works without a calculator, it is negative 0.5 times negative 0.5. Now, if I put that as a fraction, 0.5 times 0.5, hopefully you remember with fractions you multiply the top together, 1 times 1, and then negative 1 times negative 1 is 1, and when you times the bottom together you get 4. Okay, but with the calculator you just type it in and you end up with a quarter. 0 squared is going to be 0. Now notice what happens when I start heading the other side. 0.5 squared is a quarter. 1 squared is 1. 2 squared is 4. I'm actually getting the same numbers that I did with the negatives. Why is that? Hopefully you're thinking that. Because a negative times a negative is a positive. And so you end up with the positives on the left and the positives on the right. Hence why you end up with a curve that reflects itself, because the y values are the same. So when I go to plot these, for example, I get negative 14, 16, which is up here. Negative 3, 9, so that's in the middle about there. Negative 2, 4, 1, 1, 0, 0, 1, 1, and I do the same on the other side. Now, when you've plotted all your points, which I've just done there for you, you sketch the curve. You do not use a ruler. You sketch it neatly, use a pencil. A bit of practice helps. Okay, and I often find it easier to start on the top right and come back down to the curve. Okay, do arrows, because in actual fact that parabola does continue on forever. We've just happened to gone from negative 4 to 4, but if I did extra values it would continue to go up.